if I am visible. I believe I am. Yo, it's 8 seconds. I can see myself. The thing is loading. I guess I should wait for some of the guys to join. Some of my boys. I already have a viewer. What are the chances that it's just me? It's probably me. Anyways, I changed the UI again. Woo. So I'm using a gradient now. I like gradients. And what I'm going to be doing is I'm going to be creating my engine once again. And in this video, in part 2 of my series, what I want to do is I want to basically get a cube running so that I can load a particular shader and then draw stuff using it. It's pretty much the gist of it. And before we start that, what I wanted to make sure was I created a struct settings in the middle of my previous live stream, and then I just didn't use it. So I'm going to use it today, and then I'm going to build on top of it. So I'm going to go to my application.cpp, and in SDL create window, what I'm going to do is I'm going to say settings : whatever I use the name, title .c_str. And since I'm using settings.h, it's included. So I included it and I didn't use it. Wow. Okay. Window was undefined. I'm just going to make this in a vertical line so that it's readable. Okay, now this is our width, so I'm going to say settings : width. Yeah, width. And this is going to be settings : height. So basically what I'm doing is I'm accessing the static variables, but I haven't set them anywhere. So I'm going to go to settings.cpp and I'm going to initialize all of them. So I'm just going to copy every value over here. And yeah, I'm just gonna say, oh, by the way, how do you like the music? I love this. God damn, it weren't for that string. So basically what I'm doing is I'm initializing static variables as I normally do. The reason I'm looking over my mic is basically I just want to see where the alt key is. I keep forgetting. So my FPS as a baseline, it should be 60. I haven't done any frame limiting just yet except for the vertical sync, but that comes much later. That's fine. My title is going to be, let's just say, serial engine. My width was 800 and my height was 600. When I run it, it's going to show up on this monitor itself, hopefully. It works. See? I don't know why it took so long, but it worked. I guess first time I'm running it or whatever, and I'm getting 60 FPS even though I shouldn't be. And right now I'm not going to add any of the frames per second limiter. That comes much later. Or much later, in the next stream. And so in this one, what I want to do is I want to basically get a cube onto the screen. And for that we are going to set up a shader class. So what we are going to do is, first of all, there is something that normally what people like to do is they like to create a game class and an application class. I haven't seen what the benefit of doing that is, so I'm just going to put everything in application class. I don't see the need to create unnecessary objects. It's not optimal. I'm using both of these fully, so there shouldn't be any reason. So what I'm going to do here is I'm going to say nothing. I'm not going to say anything. I'm going to create a new class. You can use Shift-Alt-C. I keep forgetting. And the class is going to be called Shader. Lol. Shader. I hope that there are people actually watching. Whatever. So now what we want in our shader class is so what the shader is, it's basically information on how to run, like how to do what I want it to do, like how to display things onto the screen. And for that we're going to need a whole bunch of stuff, but for the main thing we need is we want to include glad. So glad/glad.h. And I am kind of torn between whether I want to include my own I want to create my own mathematics class, or do I want to just include GLM. I'll figure that out later. Like right now I don't need it. So what I'm going to do now is I'm going to say unsigned int id. So this is the identifier of what program is loaded into the graphics card right now. So what it does is, in the graphics card, it kind of stores the entire program, and it gives you an ID, like at this ID this program is running basically. So in our CPU all we need is the access specifier, which is our ID, and we need to figure out how to attach our program into the graphics card relative to that ID. So what I'm going to do is I'm going to create a constructor for our shader, and I'm going to say it will take in a bunch of stuff actually. So it'll take a string to my vertex path, and a string to my, what is it called, fragment shader. Yeah, so fragment path. So what I'm going to do is I'm going to use this to basically say, okay, you go to this path and then you go to this path and you load the shader that are in these files. So I'm going to create a declaration/definition, and I'm going to go to shader.cpp and write it over there. So let's go. Alright, so here what we will need is so first we're going to take the path and we're going to actually load the code into a string. And since we're using string, we need to include iostream. Yeah, so it will be vertex code and std string fragment code. Alright, so I'm going to load my stuff into these strings. And I'm also going to have to read them from a file. So I'm going to need std_stream for the vertex file, and an std_fstream for my fragment file. Incomplete type is not. Alright, I have to include this. Include f_string. Is it f_string? Yeah, the error went away, so if the error goes away, it's fine. And now what we're going to do is we're going to say one second. Yeah, vertex file dot open, and in there I'm going to give it the vertex path. Same for my fragment shader. So fragment file dot open fragment path. It's very like redundant code, but don't worry, it's going to be even more redundant when we get to creating this thing. What's it called? I forget words. When we create a geometry shader. I'm just going to put you guys to the side. It's hard to see what I'm doing. this is much worse. But I need like a triple monitor setup next. Alright, so what I'm going to do is I'm going to say I want to read the buffer now and I want to store it into the string. So what I want to do is vertex code is equal to vertex file dot read buff. Is that what I want to do? Yes. Wait, no, I want to create a stream. Okay, right. std string stream. And it's going to be, let's just call it vertex stream and fragment stream. So yeah, I have written this code before. That's why I'm just using that as a reference, in case you guys were wondering. And I don't want to copy and paste. That's like an ego thing. So I've opened the file and incomplete type not allowed, right? Include stream. So fstream and stream. And now in my fragment stream, I want to add my fragment file.rdbuff. So rdbuff is basically read buffer. It just reads the whole file, puts it into the string stream. And now I'm done with the file. I'm going to close the file. So I'm going to say vertex file.close, fragment file.close, and now I will put the stream into my string. So I'm going to say vertex code is equal to vertex stream dot str. str basically converts the string buffer into a string stream. For anybody who is using Java or something, this is basically the same as a string builder, I guess. Not 100% sure on that. I don't like to use Java actually. I think it's like a very messy language, but that's like my opinion. I am going to write C very messily, so it's like the same thing. And now what I'm going to do is I'm going to say, what am I going to say? Right, I want to, so when I'm loading the shader, I want them to be in a const char star. I don't remember what it's called. Anyway, so I want to load the shader. Now every time what happens is I forget how to load the shader. So yo Abhinav, hey, what's up? I didn't read the chat, sorry. So I'm going to go to learnopengl.com. That's like the prime knowledge source. And what you should do is you go to getting started, you go to shaders, and you see how they are doing it. They are doing it well. It's just how to write a shader. Just load the shader first. Oh my god. Okay, there's a whole bunch of try catch. There it is. So you need this stuff. Okay. First you want to compile the shader. So you're going to say create shader. Go to shader source. So basically what this is doing is it's putting the code into the graphics card, then you're compiling it, and then you are getting IV. I don't know what IV is, like intravenous. And then you just do the same thing for the fragment shader. So I'm going to copy this and I'm going to, actually should I copy this? I should not, right? I'm going to type it just so that it's a learning experience. So I want an unsigned int. I'm going to use GLUint just to be that meme where you don't copy somebody's homework. So it's a GLUint. Okay, fine. It's going to be vertex and fragment. And then I want a regular integer that says success. So this one I'm copying like wholeheartedly because this is just error logging. Like you shouldn't tamper with it too much. So my vertex is going to be create shaders. Okay, I always remember gen buffers before I remember create shaders. And the type of shader I wanted to create is GL vertex shader. Yeah, that's it. And same thing for my, now I'm going to do vertex completely first and then I'm going to do fragment, because what happens is it's going to get confused. Like by it I mean me, I'm going to get confused. So now I'm going to load my shader into the graphics card, and the way I'm going to do it is I need a GLU into my shader. I have that. And then I need a count. Okay, so how do I get my count? It says 1. Okay. Oh, this is the count, like how many shaders I'm loading. I want to load 1 shader. That's it. Then my const string. Okay, for that I need to load my vertex code. Yeah, good going. Vertex code dot c string. Const char star is incompatible with parameter of type const gl star what data. Maybe I need to put the reference to it. Is that how it works? Special must have a pointer type. Okay, bracket. It's time for brackets. You know what? I'm going to put this into a const char star just to satisfy, just to appease the OpenGL gods. Vertex char is equal to vertex code dot c string. Then I'm going to put the address of my vertex char. That's so bizarre. What have they done? And ampersand v shader code. Hey, thanks for that. I found a nice royalty free library. Maybe I just load this and then it works. Now what's the length? I don't know. Figure it out yourself. So half the time when you're writing null, it just means figure it out. Oh, const char star. I'm a moron. Okay, and then we loaded our shader. Now we compile it. So we compile shader and we say vertex. And if the shader has compiled, it should show up in get shader IV. So we say gl get shader IV. Again, no idea what IV stands for. Too few arguments. Okay, so which shader did we try to compile? We say vertex. What's the name? What? P name. Okay, I think it means process name. So the process we want to check is its compile status. Sorry. And the parameter that we want to pass is whether it succeeded or not, which is the first one. So what it means by param is the parameters of this GL compile status. So what it's going to do is whatever it returns, it's going to put it into success. And now I'm going to say if I didn't get success. So normally success is going to be either 0 or 1. You can use booleans in C++, but you can't use it in C, which is what OpenGL is written in. That's why you have to use integers. integers, ints. You have to use ints. We're gonna do gl get shader info log, and we're going to put this into info log. So what we need to tell it which shader to get it from. Our shader buffer size, we need only one buffer, and it's 512 long. 512 and null. Why have they written null? I guess when they say length, they mean the number of buffers, and when they say size, they mean the number of the length of the file. And the info log. Okay, info log. So it's an array, so it's basically passed by reference directly, like without me having to do anything. I'm just going to print it out. Integersaurus. Nice. Alright, so then we just print out info log, but we should tell ourselves that this was a problem. So we say error, this was a problem in shaders, just so that I know it's a shader problem. And then info log. So it's gonna print info log, and then stdendl. Should I try the fragment shader then? I probably should not. I should not, but I will, because I am a dick. So you can just copy paste this. So I'm just going to do that actually. Control C, Control V. I already confused myself. Where was I? Yeah. So fragment. So this is going to be a hoot and a half, because I'm wasting time over here, lol. And I didn't create a fragment. Okay, fine. Fragment. So I hope you guys are enjoying this, because this is what this whole stream is going to be. How will we make games if there are no engines? If you don't have an engine, then you'll have to directly write your driver code, like I am doing actually. This stuff will actually work if you're making your own game as well. But if you are going to say like, hey, I want to create a tool so that I don't have to constantly write this code every time I start a new game, this is what that is for. It's just me being lazy, kind of. Like, you put in a lot of work right now, and then it's better baad mein. Some life lessons in this stream. Similar to fragment shader, and then you create a program, you attach shader, you link. I should show you guys, huh? Is this visible? It had better be visible. It's too big. Okay. ID equal to create program, then you attach the shader to the program, you link it. Okay, fine. Get program IV, and then okay, it's pretty much the same as loading the shaders. So I'm just gonna put this back in its place where it belongs. I'm gonna go to shader.cpp. Hopefully I don't have to include anything else from now. So what I'm gonna do is I'm gonna say ID, which is this one over here. Yeah, this one. I'm gonna say gl get program. No. See, you can't see my notifications. That's why I put myself over here. Nice, now I'm very smart. I need to check it though. It's kind of urgent. No, it's not. Oh, it's not. They deleted it. How nice of them. Okay, gl create program. So it's going to create a program. It doesn't know what program it is, because the program is basically a bunch of shaders put together. So I'm going to say GL attach shader. I wonder if you can even hear that I'm putting a note. I'm getting notifications right now. So I'm just going to attach my vertex and fragment shader. Yeah. And then I'm going to link it. Yeah, it takes the ID. Why did I use GL uint for this when I didn't use it for the program? Whatever. I have like vague memories anyway. So then we just say GL get program IV. So programs are loaded like very similar to shaders. There are multiple, except I don't know why it's different actually. Like it gets me. The P name. We want the link status. Is that link status, and the parameters we again want it to be in success. So if it's a failure, we want to print it. I'm going to get the same code from here, paste it here, and instead of get shader info log, it's going to be get program info log, and this is going to be ID. See, it's literally the same code 3 times, and then it deleted the shader. I'm just going to copy paste that. I don't want to use it twice. Now this is a class. Okay, so I want it to be a struct. Remember, I made that bad coding practice in my first video. I'm going to continue that till I fail. So that was the like how I create a shader. I'm going to close this and I'm going to say void use, and in use what you do is you say GL use program and the ID of the program that you want to use. Wait, I'm thirsty. I hide it behind the monitor because there's no space in front of it. Also, if I keep it in front of the monitor, I'm going to drop it. Right, and then there's a whole bunch of set this, set that, whatever. Okay, so we have made our shader. Now what we want to do is we want to create our cube. Now this is where it gets kind of tricky. I mean, it was always tricky. Where's paint? I don't have paint open. That's fine. Do this every time you copy and paste the code. Lol. Alright, so when I want to draw a cube, what I'm going to do is I need to create what's called a vertex buffer and an indices buffer. So I'm going to create like a bunch of stuff. For that, what I need to do is I need to create points. So I'm going to say these are my points, like for my cube. It's not going to look, sorry, I'm going to use a different color for the lines. Hope you guys enjoy the music. I'm just using it to cover the silence. You might be wondering what is the logic of me choosing these colors in particular. There is no logic. Oh wait, there's going to be a point in the back as well. Sorry, like 8 points to a square. Should have done back first. but then I would be too much like OpenGL. Lol. Just pretend these are connected. I don't want to use green. Green is a dumb color. Yeah, all the green fans are going to be angry at me. I like this music, it's very jazzy. And let's just use pink. Is pink even visible? Ah, fine, I'll use green. Green is the bottom dweller color. Look at that. Pathetic green. I have really strong opinions on colors. Okay, so I basically use different colors to denote the side. And what this is doing is I'm going to say, okay, this is the back face, this is the front face, this is the up, right, left, down, basically like that. So what I'm going to do is I'm going to say, okay, these are the points that you need to draw. So it's going to be in 3D space. There's going to be 3 points. Normally what people like to do is they like to get a triangle. I should also get a triangle first, and I'll get the first triangle first. So what I'm going to have to do is I'm going to have to divide these into different triangles like this, just to be like efficient in the long run. So what this point is going, it's in red. So this point is going to be negative, let's say -1. No, yes, no. Let's have it be 0.5 right now, since we're doing it in orthographic projection. So it's going to be -0.5, positive 0.5, and positive 0.5. I don't know. I'll have to check for that. And this point is going to be, why is there only cubes and rectangles? There's no reason, it's just a very simple shape. You can have pyramids. In fact, let's make a pyramid. Let's get rid of all this. Thank you for wasting all my effort. So I'm not going to color code it this time. Okay, let's just have it be a pyramid. I'll just need 4 points, and it's going to be like this, like this. So one face is going to be like this, one face is going to be like this, one face is going to be like this, and one face is going to be like this. I hope this makes sense. I'm gonna use different colors, fine, got me. So it'll be like this. I don't know how triangles are made. Definitely don't have 4 corners. One is like this. And let's not use yellow. Let's use a dark color so that you can see. Okay, so these are different color faces. And so we are going to start with the orange face. And the orange face is going to be, I'm going to make it over here. So my orange face, first I'm going to start with this one, and this will be at the top, so it will be 0, 0.5 and 0. So X, Y and Z. Should be in black, just pretend it's black. Actually no, it should be orange, fine. And then we're going to do this point, which will be negative 0.25. I'm trying to visualize what a triangle looks like in like projection space. And my Y will be negative 0.5, and my Z will be, just have it be a back facing triangle. So actually, you know what, I'm going to make it 0.25. Then the third side will be third vertex will be positive 0.25, negative 0.5 and 0.25. So what I did right now was I basically imagined a graph and I said, okay, at what points, like what are the points that I need to create a triangle? So I said, okay, I need somewhere over here, so that's 0, that is this point, then one over here and one over here. And then what my shader is going to do is it's going to connect these, maybe not in this order but in some order, and then it's going to say, okay, so this is what the vertex shader does. It basically connects these two, connects these three lines. Then my fragment shader, what it's going to do is it's going to say, okay, what color do you want it to be? And so when we color it in, it's going to be like this. This is exactly what the fragment shader does. It takes like multiple rounds and it leaves a lot of gaps. So that's how our triangles are drawn. And then you use these triangles and you create a whole bunch of nonsense. So here what we are going to do is I'm going to include shader first. It's application.h. So I'm going to include shader.h. And yes, it is kind of dawning on me that I don't know what I'm doing, but let's have the existential panic for later. Oh, I can't see the chats. Right. So we're going to create a shader and we're going to say shader. How original. I'm going to start with pointers right away actually. Is equal to new shader. And the reason I'm starting with pointers right away is because there's no reason actually. It's because I'm going to be using it later, so it's like best to get a habit right away. So what I'm going to do is I actually don't like using Visual Studio Code for this. Visual Studio. I like using Visual Studio Code. So I'm going to go into my project files and I'm going to create a new folder. And the folder is going to be called resources, if I remember how to even type. And in here I'm going to create a folder called shaders. And I'm going to open this folder with code. Now I'm going to wait for half an hour because it takes forever to load. Fine. Okay, fine. So now this can be any file format you want. What I like to do is I like to save them as GLSL and use the Hungarian notation. I said in the last video that I thought having the file name be like in camel case is a Hungarian notation. That was wrong. Hungarian notation is basically saying what the file is, what the variable is supposed to do. So I'm going to say v default shader, I don't know, and then I'm going to save it as a .glsl file. And the reason I'm saving it as a GLSL file is because I have syntax highlighting for that file, and then I need two files like that. So I'm going to have f default shader .glsl. Don't copy my file. Where did it go? Oh, fine, it's here. Alright, so we are going to write our first shader, and by V I mean I'm going to copy it wholeheartedly from here. So let's go here. This is the wrong one. Alright, 3.3 shade. So what they did was they said they're going to say .vs and .fs. So as you can see, the file name doesn't really matter. And it's a very basic shader, so it's like, go for it. may have put it in the wrong order. Yeah, this is the vertex shader. Oh my god. Okay, so in our vertex shader we are basically setting a position, and our fragment shader we are setting our color. Just close all this and then we just save. Now I don't hopefully have to ever look at this again. You know, close this and close this, and I'm going to hide this over here so that I don't embarrass myself completely. So now what I want to do is, in my shader I'm going to actually put this file. So I'm going to say resources/shader/s. Please don't look at my folders. Why did I open this? You can just go from here. Okay, resources, shaders. Okay, there's an S and everything, and my words start with a capital letter. How do I get so good at English? And our first thing is our first shader is vertex shader. So I'm going to say vertex vdefault shader.glsl and resources/shaders/f default shader.glsl. And now what I need to do is I need to give it a bunch of information, like how I'm going to draw my my stuff onto the screen. And for that I'm gonna go again to learn OpenGL. This is basically me following a tutorial and just weirdly putting it into my this thing. So my engine, sorry. So we're gonna say, okay, vertex input. So what they have used is they have used 0.5. Okay, they have used a different kind of triangle. We're using it in 3D. It's going to be slightly different. I don't know if we want to use this one. We want to use it. We want to use the later one. My nose is itching a bit. Okay, and they've just created the shader like locally. Then you used vertex attrib pointer. Vertex array object. Yeah, so this is what we want. We want element buffer objects. Atharva, yo, what's up? How's the music? I got my royalty free music like you asked. Alright, this is it. So it says unsigned int EBO, and then it generates the buffer, it binds the buffer, it puts the data into the buffer, then it binds the buffer. What? Okay, this is when you're drawing. Okay, fine. So it binds the buffer and then you draw the elements. You didn't have to bind the vertices. That's weird. No, that can't be it. Okay, so we create a vertex array object, VAO, VBO, and then EBO. So we bind vertex array object, copy our vertices array in a vertex buffer for OpenGL to use, copy our index array in a element buffer, fine, for OpenGL to use, and then we set the vertex attributes pointers. Okay, it doesn't seem right, but fine. Ooh, you can then do this. I'm not gonna do wireframe mode. I don't care about all this. So GL bind vertex array. Yeah. Fine. So I'm going to do that over here. Like I'm going to do it outside right now, because ideally when I'm loading, it's going to be like right before I run. So I'm going to have it on my other monitor. And this is all temporary. So let's create our array first. So let's have it be vertices. And the reason I'm creating a different array for vertices and a different array for indices, it's going to be clear when I make the rest of the triangles. So where's paint? Okay, just copy it from here. So we want it to be 0, 0.5 f and 0. So that's our first vertex. Then we want negative 0.25, negative 0.5 and 0.25. Then we want 0.25, negative 0.5 and 0.25. How this will work, I'm not entirely sure. Like, okay, fine, I am kind of sure, I know what I'm doing. It's like, it's a bit bizarre. And my indices, fine. Indices is going to be like, depending on who I'm talking to, I like to say indices sometimes. So what I wanted to be is, it's not going to be in this order. Click select, why didn't it do that? So the triangle I'm drawing, I'll just draw it again. Why can't I? God damn. Alright, so in my graph I have 3 different points, 1, 2 and 3. Not in the, so that's the order that I want to draw them in. I want to say draw this one first, draw this one, and then draw this one. So this point is over here. Just select black. Jesus. Jesus. Fine, let's pretend gray is the color that I was trying to select. So this will be 2, we already know. This is the left half, so this will be 1. And then this will be 3, the remaining one. But what we want is, let's have it 1 indexed actually. It will come in handy when we are loading OBJs. But it won't. Okay, fine. This will be 1, this will be 0, this will be 2. Arrays are 0 indexed in your graphics card. Fine, so this is what we do. Then we get on to copying code from here. So what I'm going to do is, 1 second. Damn, I was covering that. Why are you using OpenGL instead of Vulkan? Okay, so I should clarify this right now. Let's go to vulkantutorial.com, the prime source for everybody learning Vulkan. So it seems like it's pretty simple, right? So what's going to happen is, you say, okay, drawing a triangle. Okay, there are like 4 steps: setup, presentation, graphics pipeline, drawing, and then swap chain recreation. But then you open you open setup. Okay, there's a whole bunch of base code that you have to write. Then you create an instance, there's validation layers, physical device in queue families, logical device in queues. Then there's presentation, you create a window surface, a swap chain, image views. Then you create your own graphics pipelines. This is like basic how to create a shader. This is fine. Then you create a render pass, draw conclusions apparently, fine. And then you actually start drawing. So it's like there's so many steps. If I was drawing a cube in my Vulkan engine, I would be in part 40 or something, because one, I don't even know how to use Vulkan. I barely know how to use OpenGL. But more importantly, I barely can I don't have the time basically. Okay, where was I? Oh no, Abhinav, don't cry. Don't make me sad. Alright, so what they did was they used an unglu int and they said VBO, VAO and EBO, and then they initialized these. They said GL gen vertex arrays and they put in the VAO 1 and then ampersand. Okay, fine. And then they just generated some buffers. So what gen buffers is, it's basically you are allocating space basically. This is malloc, but better because it's not malloc. All my C programmers know what's up. So it's VBO and EBO, and this one is basically the number of vertex arrays that I'm trying to create. One sec. Right, so we bind our vertex. So we say GL bind vertex array. So ideally, if I was working over here, I would say, right, okay, you generated the vertex array, you should bind it right then and there, right? But what happens is most of the time you'll be generating it and then you'll be binding it separately, because you'll be like, oh, this is in the constructor, and then like 5,000 lines of code later you'll be like, okay, now I want to start using my vertex array. That's why it's like this. Okay, now we bind our buffers. Bind buffer. Whoa, what is that? And we are going to say GL. So what kind of buffer it is, and what else do you want me to pass? Oh, the 3S, fine. And then the buffer that we want to give it. So what buffer do we want to give it? Our vertex buffer object. And then we are going to put, so now that we have basically opened our file, that's what bind buffer does. We're going to give it some data, and the kind of data we are giving it is, so first we tell it what type of data it is. It's an GL array buffer. You'd think it will be able to figure it out itself, but it doesn't. Then the size will be a size of vertices. Sorry, my keyboard is acting up a little bit. And what data do we want to pass it? Our vertices. Simple. And the usage. Okay, so this is basically what we are using, like how we are going to be using this data. It will be GL static draw. So there is static draw, and I believe there's GL dynamic draw as well. And basically what I like to think of this is will this data change, and what is it being used for? So if you think, okay, the vertices might change, then you'll say GL dynamic draw instead of GL static draw. And then I believe we do the same thing for our EBO. Right. So we say GL bind buffer, GL array buffer. It's an element array. Fine. Element array buffer, and then we give it EBO. And then we say GL buffer data, GL element, yeah, god damn. And then we pass it the indices the same way we passed it the vertices. Keep forgetting what I'm trying to say. And what are we going to use it for? GL static draw. Okay, fine. I would have assumed static read, but it says static draw. I will try it after it runs for the first time. Fine. Then we say GL vertex attrib pointer. What does it do? Actually, I should show you. Fine. Oh, good. Nice. They wrote a whole Mahabharata on it. Can't even read it, bro. Okay, the function GL vertex attrib pointer specifies how OpenGL should interpret the vertex buffer data whenever a drawing call is made. The interpretation specified is stored in the currently bound vertex. So it takes index size type normalized stride pointer. Fine, let's do what they say. And I might have to open that shader file again because I don't see where we are like putting in layouts right now. If I was an actual graphics programmer, I would have caught that by now. Vertex attrib pointer. So basically what we are doing is we're setting our cursor. So like we're telling it, okay, our cursor is here, and then one vertex is, I'll just show you how we are doing it. So we give it our index is 0, so it will start at 0 and then at 0 bytes basically. And then what is the size of a byte? The size of 1 byte is how many data points are we storing? So we are storing 3 vertices, so 3, that's what I've put here. Then GL enum type, it's of type GL float, isn't it? Yeah, Tharva, remember, isn't it? Okay, is it normalized? It is not, so GL false. What is the length of one stride? So the length of one stride will be the size of a float into 3. So a stride is basically how much it should jump at once. So it'll be like you're over here, and then when you jump, you should be somewhere over here. So you jump 3 floats ahead. And then what was this? Const void pointer. I don't know what this is. I'm just going to copy what they said. Void star 0. I guess we're just not using this. Maybe we can pass null, but we have to convert it. Okay, so we have set how our cursor should move. Now we enable it. Okay. Wasn't enabled until now apparently. So GL enable vertex attrib array, and we have to pass it 0. Okay, what does this do? I'm not entirely sure. Let's read the documentation. The function GL enable vertex attrib array enables a generic vertex attribute. A vertex attribute can be disabled by Fine. Just thanks for that explanation. Jesus Christ. Fine, so we bind buffers again. And okay, so what we're doing is this line is basically telling me, okay, you close all the buffers. Hopefully if I accidentally like say GL buffer data, I shouldn't write into an already existing data. And then same thing for my vertex array. That should be it. Now normally you do it in render, but I'm gonna do it not in render. I should do it in render. Fine, I'm going to comment this out. I'm going to put this here. And the reason I'm doing this is because all my data is over here, so I don't want to like have to create it globally and then reference it in two different functions. I can just do it in one place. And this is just for like testing stuff. Later when we create our own entity component system and whatever, this will come in handy. You know, I kind of knew we would go over. This is like way over. Fine, then we say shader use. So we're using a shader and we say GL bind vertex array. Most likely I'm going to have an error because I keep forgetting to change my shaders. Say GL draw elements. Okay. And the kind of elements we are drawing are triangles. Sorry. How many triangles? I don't know, 6. What? 6? Why 6? This makes no sense. Then what type? GL unsigned int. What did? Hey chat, can somebody help me make sense? What is this GL draw elements? The function GL draw elements draws count indices in. Okay, how many? Oh, there's 6 indices. Okay, fine. We only have 3, so we draw 3. But how is it GL unsigned int? Oh, I got it. Got it. This is not supposed to be float. This was an unsigned int. Good work, team. I figured it out. GL unsigned underscore int. Okay, this might be buffering for you guys right now. I'm so sorry about that. I'm gonna close my YouTube right now. I can read the chat over here as well. And then indices. Okay, this is where to start from. So you can just pass it 0. And the rest is just draw code. So when I run this, it's going to give me an error. I know for sure. And the reason it's going to give me an error is because the shader is coded wrong. So where do we get the right shader? It's over here. Nice. Just gonna copy this. And I know I'm being a bit of a dick right now by like not doing it the right way. Like they have the source over there as well, like proper source, but I just want to like force myself into reading what I'm doing. It's what I like to do. So version core 330 at location 0. I just need to give it my position, like what the vertex that I need to draw. That's why it's a vec 3. If you used Unity, this is the same as vector 3. Should be an indentation, but I do my own indentations. Right, so this was a vertex shader. So out vec for frag color, void main, and then we are basically setting our frag color. Alright, we have set up our shaders. Now when we run it, please for God's sakes work. Why? Okay, शेडर काम कैसे करेगा, लाइक मेरा गेम ऑब्जेक्ट को कैसे ड्रॉ करेगा. ओके, fine, I have obviously made some mistake over here, so I'll fix it later, like off camera. I'll just answer this question and then I'll wind up. So I'll actually use their diagram. One second. They have a very neat little diagram of like how a shader works. Huh. And you asked in Hindi, so I'll answer in Hindi. जब मेरा शेडर जो है वो जब मेरा एक गेम ऑब्जेक्ट ये होता है एक बना है, तो उस गेम ऑब्जेक्ट का बहुत सारा 3D ये रहता है, कोऑर्डिनेट्स रहता है. मैं यहाँ पे दिखा देता हूँ. मेरा एक दूसरा यहाँ पे है. हाँ, ये जैसे cube.obj है. अब मैं इसको खोलूँगा तो यहाँ पे देख सकते हैं कि बहुत सारे पॉइंट ऐसे वर्टाइसेस हैं एंड यहाँ पे उसके बहुत सारे इंडेक्स है. तो ये एक क्यूब का वो है डिफ़ॉल्ट, मैंने ब्लेंडर यूज़ किया था बनाने के लिए. तो यहाँ पे वर्टेक्स का बहुत सारा इन्फॉर्मेशन है, यहाँ पे फ्रैगमेंट का बहुत सारा इन्फॉर्मेशन है. अब मैं क्या करता हूँ कि इसको वही VAO EBO करके ज्वाइन हो जाता है वो. आई थिंक आई नो कि इसका क्या सोल्यूशन है. एक मिनट. That's not what I expected, लेकिन बन गया. I have a triangle on screen. Fine, I'll explain what I did after I answer your question. So मेरा जब एक गेम ऑब्जेक्ट होता है उसका ये सारा डेटा होता है, ठीक है. एंड इस डेटा को बेसिकली स्क्रीन पे दिखाने के लिए वो शेडर्स काम आते हैं. तो वो जब कोड बोलता है कि अच्छा ग्राफिक्स कार्ड को बोलता है कि अब तुम ड्रॉ करो, तो ग्राफिक्स कार्ड पूछता है कि ठीक है क्या ड्रॉ करूं. तो उसके लिए बताना पड़ता है कि ये पॉइंट्स है, इस ऑर्डर में तुमको ड्रॉ करना है. तो वर्टेक्स वाला सारा डेटा पहले जाता है वर्टेक्स शेडर में, जिसमें वो वर्टाइसेस ड्रॉ करता है. एंड देन वो फिर उस शेप को असेंबल करता है पूरा लाइन वाइन बना के. फिर वो ज्योमेट्री शेडर में जाता है. ज्योमेट्री शेडर में वो बकवास करता है. ये उतना इम्पोर्टेंट नहीं है. ज्योमेट्री शेडर नॉर्मली बहुत कम लोग लिखते हैं. अगर जैसे वाटर के इफेक्ट्स ये सब बना रहे हैं उसके लिए काम आता है, अदरवाइज उतना इम्पोर्टेंट नहीं है. माय कंट्रोवर्शियल ओपिनियन. एंड फ्रैगमेंट शेडर जो है वो क्या करता है कि वो पूरा लाइन बाय लाइन जाता है और बोलता है कि अच्छा इस वर्टाइस का ये कलर है, मैं इस हिसाब से बाकी सब का आसपास के कलर्स को भी फिगर आउट करके वो दूंगा. ओ हाँ, इस ऑर्डर में. तो यहाँ से ऐसे गया यहाँ नीचे आया. तो ये रास्टराइजेशन है, ये मेन है. तो हम लोग का ग्राफिक्स कार्ड फिर क्या करता है, एक बेसिकली एक फॉर लूप जैसा करता है. और वो बोलता है कि मैं यहाँ से ऐसे जाऊँगा, फिर यहाँ से ऐसे 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 करते हुए नीचे जाता जाएगा. एंड वो देखेगा कि यहाँ पे अच्छा यहाँ पे मुझे ड्रॉ करना है कि नहीं। तो इस पिक्सल में मुझे ड्रॉ करना है तो मैं ये वाला कलर जो भी है शेडर से मांग के ड्रॉ करूँगा। बेसिकली वो लॉजिक है। तो शेडर वैसे काम करेगा। अब इसमें क्या प्रॉब्लम था, वेयर इज माई कोड, आई डोंट नीड दिस एनीमोर। सीरियल इंजन, हाँ। तो मैंने यहाँ पे GL फ्रंट फेस लिखा है काउंटर क्लॉकवाइज, लेकिन मैंने उसको इन्फॉर्मेशन दिया था क्लॉकवाइज और बंद कर दिया वो पेंट। हाँ, so I gave it the information. It's yeah, it was 102, right? So it's 1 and then the top and then the side. So it was drawing it counterclockwise, and then I said GL cull face the back, cull face back, and the front face will be drawn counterclockwise. So it said, "Acha, it's clockwise. That means that this cube is at the back, so I don't have to draw this." And that is why it wasn't working. But now it's working. And then you can just play around with these points, I guess. So if I make this 1, it should reach the end of the screen, and first it should give me an error because this is supposed to be 1.0f. If you use C#, it will work better. Look at that. Whoa, I have a triangle. So I don't know why it's giving me this kind of problem. It shouldn't. I think I've messed up my coordinates a little bit, but I'll fix that off screen. For now, this is it. We have a triangle on screen. In part 2 of let's draw some cubes, we'll actually draw some cubes. And in this one, the last thing I want to say is I have another stream actually scheduled in 1st of September, I believe. Where's my calendar? Yeah, so in the 1st of September, alright, you couldn't see it. So in the 1st of September, I will be solving some more HackerRank questions. I have, what's it called? Arrays as the interview question. So hopefully we'll be able to solve all this if we have your good vibes, if I have your good vibes with me. So be sure to join me then and there. Remember, 1st of September at 4 o'clock. I'll see you then.